Okay, this is the key for exercise set 2.3. First one is just power rule. So if you remember, x to the power of n becomes x times n to the times n minus 1. So this one's going to become 3x, 2 times 3x squared, because you bring down that 3, which is 6x squared. This one will become 8x to the 7th minus 2x. This one will be negative 12x squared minus 2, and the 5 is 0. So you leave that one. And this one, you're going to treat this as an x. You don't always do that, but for this period of time, we're not going to get into examples where this is not true. If you just have a regular x and a constant in here, you can apply a power rule. So this becomes 24x plus 2 to the third. This one, again, this is just a regular, you can treat this as an x. So this would become 10x plus 7th to the ninth minus 60x to the fourth. Again, treat this as just an x because it's just an x and a constant. You can do that. 6x minus 3 squared. Same thing here. Plus 8x plus L. It's like a weird L. Okay. And these are all fine. Okay. 2. If a function is increasing, such as one on the right, what is true about f prime? So we did this today, or the derivative. We did this today. This is, so you want to look at your sort of vocab sheet. So if the function is increasing, that means the derivative is positive. Like right here, we are increasing, right? So the derivative is positive. Okay, so right here, positive. The derivative is positive. Okay. Use your idea to algebra to determine where this is increasing. So I'm actually going to come back to this at the end. This is not going to be assessed on the test. So I'm going to do this at the very end, but I'll come back to this. Okay. The graph below consists of 4 line segments. Draw df dx on the coordinate grid. So this, again, this is the derivative, which you're thinking, in your head, you're thinking slope of tangent. Like, that's what you're thinking in your head, right, when you draw the derivative. So here, we're looking at the rate of change. So from negative 4 to 0, we go up 2 over 4. That means my slope, is 2 over 4, the rise of a run. I went up 2 over 4, which is 1/2. So that means from negative 4 here to 0, I should have a horizontal line at 1/2 because my slope is constantly at 1/2. This should just be a straight line over. Okay. Then from 0 down to 1, I go down 1, 2, 3, 4, so minus 4, and I go over 1. So that means this slope would be negative 4 over 1, which is negative 4. So for a brief time, 1, 2, 3, we have a derivative down here at negative 4. Let me try to make that as clear as possible. Okay. And then from 1 to 4, notice that this is a horizontal line, right? So we're not increasing or decreasing here. So this is m equals 0 because there's no slope. So here you would kind of be, I'm going to emphasize this, from 1 to 1, 2, 3, 4, this is all 0. And then last, from 4 to 6, I go over 2, 1, 2, and I go up 1, 2, 3, 4. So again, up 4 over 2. So m would be 4 over 2, which is 2. So I'll jump up to 2 from 4 to 6. 1, 2, 3, 4. 1, derivative. So it would look like this. Okay. So you look here, what's the slope at those points? That's the derivative. For each graph, sketch the approximate graph of the derivative using a different color. Okay. So here we have, it doesn't have to be exact, but we can see we're kind of going down to over maybe 4. So that means down to over 4, negative 2 over 4 again, rise over run, which is negative 1/2, which means I should have a horizontal line right here at negative 1/2. Okay, here we are going, again, when you have curves, this is when you would start drawing a tangent line. So here we have positive slope, and then we have a 0, and then we have a sort of a negative slope, and we have another 0, and then we have positive slope again. So a good way to start with this is to mark our zeros. So this is where our derivative will be crossing the x-axis, and then you're gonna follow your trend. So this is positive, and then we're negative. So this is 0, positive, then 0, then negative, then 0, then positive again. So that's what my derivative should look like. It should be positive, then come into 0, then negative, then come into 0, and then positive. So this right here would be the derivative. So again, look at the tangent lines, mark their signs, and then draw. That's my advice. Okay. So in steps, 1, tangent lines, signs, like plus, minus, or 0, draw. Okay. So let's look at this one. We have positive, 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 right? To 0, and then negative, 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 negative. I'm going to put more pluses when it's steeper. So look, steep, less steep, less steep, 0, negative, more negative, more negative. That's what I'm kind of showing here. So we're going to start high, positive, less positive, less positive, 0. See, I'm at 0 when I'm at 0, little negative, more negative, like this. This is not perfect, but it's roughly what it should be. Okay. It might be some variance of this, but it should look like this. And going up, getting more positive here, going down, getting more negative here, and absolutely 0 here because our tangent line here is 0. Okay. Given that 6 times the square root of x minus 2x to the 7th, find the derivative. Again, this means the derivative. So we have to convert it to exponents. So you're going to get 6 x to the 1/2. That's because the exponent's 1, the root is 2. So it's 1/2. Minus 2x to the 7th. And then we're going to do power rule. So we can do it one at a time. For 6x to the 1/2, we're going to take down that 1/2. So we're going to have 6 1/2 x to the negative 1/2 minus, bring down the 7. So we're going to have 2 times 7x to the 6th. This simplifies to 6 times 1/2 is 3x to the negative 1/2 minus 14x to the 6th. And this is fine. I accept this, but if you want it more simplified, this would become 3 over the square root of x minus 14x to the 6th. Okay. So these are fine. Either of these are fine. Next one. So again, this is derivative notation. Derivative given that y minus 4 times 2y. This is w of y. So we cannot apply power rule until this thing is simplified. So what you have to do is multiply these out. You can multiply them out by foiling, distribution. I'll do the box just like to keep that in your mind. When you're multiplying here, we have y minus 4, and then 2y plus y squared. This is 2y squared, y to the third, negative 8y, negative 4y squared. Altogether, we have y cubed minus 2y squared minus 8y. So then this, I'm going to move up here, y cubed minus 2y squared minus 8y. So multiply. Okay. Now I can find the derivative of this. So this is 3y squared minus 4y minus 8. Power rule. Okay. Next one. Again, okay, so this one, not on the test. I'm going to do this one last. I'll come back to it. And then number 8, not on the test, but on the AP test. We'll talk about it later. But I'm going to do this last. And then 8, find the equation of the tangent line to g of x is 16 over x squared minus 4 root x at x equals 4. For sure, a more challenging problem. Let's first, before we get into finding the tangent line, I want to convert this into exponents that I can use. So remember, I need this in the numerator. So I'm going to move this up by making the exponent negative. So I have 16x to the negative second minus 4x to the 1/2. Okay. So I just converted it to exponents, right? I'm going to write that here. Convert to exponents in numerator. Okay. And I'll set up the situation. So we need to find a pair of coordinates, which we already are given one of them. And then we need to find our derivative. And then our b, optional. I'll talk about that too. So for our x1 is given to us. That's right here. This is x1, our first coordinate. Let's find y1. So to find y1, we need to evaluate f of 4. So, okay, here, let's do that. So f of 4 would be 16 times 4 to the negative half minus 4 times 4 to the 1/2. So you can put or you can put it into the original equation too. It's easier looking at it this way. What this comes out to is 1 minus 8, which is negative 7. So your y1 is negative 7. All that's left to find is m. Okay, so we've got x1. You get y1 by plugging it in. And then for m, I'm going to rewrite it here. So our original equation with the good exponents is g of x equals 16x to the negative second minus 4x to the 1/2. We're going to take the derivative here. So the derivative is negative 32x to the negative third minus 2x to the negative 1/2. All right, so all I did there was negative 2 times 16 is negative 32, and then minus 1. And then 1/2 times negative 4 is negative 2, minus 1 is negative 1/2. Then I need to find the slope specifically at 4. So we're going to plug that in. So we're going to get negative 32 times 4 to the negative third minus 2 times 4 to the negative 1/2. So in the calculator, you would get, let's see, so this is, I'm just like simplifying this in the calculator. This is negative 32 over 64 minus 2 over 2. Because it's 2 over the square root of 4. So what we have here is negative 1/2 minus 1, which is negative 1.5. So that's our m. So now I have x1 equals 4, y1 equals negative 7, m equals negative 1.5. And at this point, you can solve for b, right? I could do y equals mx plus b and solve for b, but because it's like quite a messy equation, I really don't want to do that. So I'm going to write down okay, it cut out there, but this is x1 equals 4, y1 equals -7, m equals -1.5. And I'm going to plug them into the point slope formula, which is y minus y1 equals mx minus x1. This equation is really, really helpful. You just need a coordinate, which is right here, 4, -7, and then your slope, and you're good. So we do y minus -7 equals -1.5 x minus 4. This is fine, but I can simplify this further. Y plus 7 equals -1.5 x plus 6. And get it totally simplified. Y equals -1.5 x minus 1. So that would be the equation of the line tangent at x equals 4. Okay. Last two questions. So I want to emphasize these are optional, but they are on the AP test. So the first one was 2B. So essentially the question is, when is 3x squared minus 3x plus 1 increasing? That's the question. Okay. And we have to do this algebraically. Well, how do we know if it's increasing or decreasing? That's the derivative. So if I have g of x equals 3x squared minus 3x plus 1, and I'm not graphing this, then the derivative can tell me exactly when it's increasing or decreasing. So we take the first derivative, which is going to be 6x minus 3, right? Now, when this is positive, it's increasing. That's what we got to know, right? When this is positive, this is increasing, right? So I'll show you a couple ways to do it. We can think about 6x minus 3 looks something like, the graph looks something like this, right? So this region here, if this is g of x, this region right here where it's positive, this is where g of x is greater than 0, increasing. To find this value right here, we're going to set it equal to 0. So 6x minus 3 equals 0. And plus 3, we'll get 6x equals 3 divided by 6 divided by 6, x equals 1 half. So what this is saying, this right here is x equals 1 half. That means that from 1 half to infinity, we are increasing. Okay? So you find where the derivative is positive. You do that by finding where it equals 0, and then the area that is positive will be where it's increasing. So it's decreasing below this. It's increasing above it. All right, that's 2B. And 7 is very similar. So again, optional, don't need to know it. But number 7 is saying, determine where, if anywhere, the tangent line to f of x equals x cubed minus 5x squared plus x is parallel to the line y equals negative 2x plus 23. Well, parallel means, right, same slope. Parallel means same slope. So let's find the slope of f of x, right? So to find the slope, we're going to take the derivative. F of x equals x cubed minus 5x squared plus x. The derivative is 3x squared minus 10x plus 1. Okay, so when does this equal the slope of this line? Well, the slope of this line is negative 2. So what I'm going to do is set this equal to negative 2. So we're going to say 3x squared minus 10x plus 1 equals negative 2. And we're going to solve this. So this is the derivative. This is the slope I want it to equal. And we're going to set it, first we're going to set it equal to 0. plus 2 to both sides. This is how you solve quadratics. 3x squared minus 10x plus 3 equals 0. Now we got to factor this. Let's see. So I'm going to have a 3x over here. I'm going to have an x over here. And then you need to add. So it's going to be negative 3 here and negative 1 here. Okay. I know that because, okay, 3x times x is 3x squared. 3x times negative 3 is negative 9x. Negative 1 times x is negative x, which gets me negative 10x. And negative 1 and negative 3 get me 3 equals 0, which means then you set each of these equal to 0. X minus 3 equals 0. X equals 3. That's 1 point. And then 3x minus 1 equals 0 plus 1 plus 1. 3x equals 1 divided by 3 divided by 3. X equals 1/3 is the other point. So at these 2 points, when I plug them in to my derivative, my original derivative here, I'll get negative 2. So that means at these 2 points, the slope of the tangent line is negative 2. Okay, that's it.